Hi, good evening. Whoops, a daisy. Hi, good evening, and welcome to the ZP Developer Zone webinar. So we like to do this webinar once or twice a week, and we really just answer technical questions from the week. Now, admittedly, the next part is wrong because I got the date here as the 23rd of May, 2024, but it's actually the 22nd of May. We've got a day early, and there's a good reason for it, and I'll kind of get to that briefly. I've got about 4 questions tonight. So the first question is electrodes for muscle stimulation. Really interesting application, actually. You know, at ZP we love biosensing. We like sensing things, but this idea about, you know, and I can appreciate what you're doing, stimulating muscles using electrical signals and using the screen printed electrode as a kind of platform for it, I think is just really interesting. I think our hypervalued carbon electrode is going to be the best view on this, and I will get to that point in a minute. Another request that's coming in from the US is a custom interdigitated electrode. I will talk about the real dangers of customization of electrodes. I've got some slides on this, and I will give you quite a lot of detail on this. So will be question number 2. Now, question number 3 has come in from India. I mean, it's, you know, I've paraphrased the question here, but it's, you know, why are ZP electrodes so good? It's not a statement. They're generally asking, you know, for evidence as to why we think our electrodes are so good or so reproducible. Question number 3, I really will be answering that. It'll be embedded in question number 2. So please, question number 3, please study question number 2 when I answer that. And question number 4, I was at a conference last week. I gave a workshop. I met a nice team from France there. And I really thought that their technology actually really lent itself to our screen printed electrodes because really of our reproducibility. And I also thought that the kind of assay that they're developing will fit really well in the long run on our SensiAll platform. And I would also say question number 2, sorry, not question number 2, but question number 3, in part why you should be using our screen printed electrodes, because if you're using our screen printed electrodes, then you're really moving yourself into the ability to actually be on this platform and get to a product, make an impact much earlier on. So question number 1, I'm going to answer that. It's an interesting question, very different from a lot of things we get, but I think it's super fascinating, so I will answer that. How to do muscle stimulation or muscle tissue stimulation using screen printed electrodes. Question number 2, I'm going to give you some real, you know, at ZP, we're an unusual company. People say, oh, well, can you do this for me? And I say, really, have you thought this through? You know, let me give you an opinion on this. I think that's what makes ZP super different to most companies, actually. That the problem is, I think in the world of screen printing and biosensing development, too many companies go, yeah, sure, I'll do it for you. It's like, really, we have to think this through a little bit more. Why are our electrodes so good? And I will talk about the repeatability. And question number 3, I also think that you shouldn't just think about our screen printed electrodes as standalone, you know, and think about the repeatability. Remember, what we're really talking about here is actually making an impact. And if you use our screen printed electrodes, you're on this device, or you're getting onto that device, and you're much quicker or closer to making an impact otherwise. Anyway, that said, the reason I've gone a little bit early this evening is because we have 2 webinars tomorrow. We have done a lot of webinars this week, but they were like academic focused. But actually tomorrow is much more about commercialization. So I need to be preparing for these. But we do have one at 9 a.m. London time in the morning and one at 4 p.m. London time in the afternoon. So I think question number 3 and question number 4, please do come along to these webinars. You find them quite interesting. If you see a link pop up, I will put it underneath the YouTube video shortly. Question number 1, electrode for muscle stimulation. So they're making artificial muscles, fantastic. Can screen printed electrodes be used? I think they can be. I've got a suspicion that the kind of voltage that you're going to be applying is not that high. It's my opinion, but I don't think you're really applying more than maybe 5 volts to this. It's voltage and current that's important. I don't think your voltage is that high, and I don't think your current's going to be that high. Obviously, not obviously, but the more voltage and the more current you pass, then the more likely you are to damage things like screen printed electrodes. Because obviously power is equal to voltage times current. but I have a suspicion that you're not actually doing that much. Otherwise you'll just, I mean, even a voltage of 5 volts will end up hydrolyzing water and therefore sort of splitting the water in the tissue into hydrogen and oxygen. You're not using that higher voltage. I think you should be fine. Can the widths and distances be adjusted? Yes, they can. But actually, what I'm going to recommend to you is you get a sheet of our electrodes, because you can cut electrodes out any way you therefore wish. And so you can use adjacent screen printed electrodes and span the tissue between adjacent screen printed electrodes. So I think you actually can, even before going to customization. Customization is an expensive process. It's not just, people are very willing to give you customization, but the problem they don't tell you is you're going to have poor quality. Quality comes through either paying a high price or having high volume manufacturing. And so question number one with your muscle stimulation, don't go very quickly to customization. Try and use what we have, and I'll try and direct you in that, or guide you in that direction. You can increase the separation between electrodes, but also the way I'm about to suggest, you can actually use adjacent electrodes. You can have all sorts of gaps between electrodes. Can the printed electrodes be thicker? Yeah, sure, we can increase thickness, but you're now going towards customization. I'm not convinced that you're actually at that higher voltage or that higher current, so I don't actually think that you need to be printing thicker at the moment. I can understand why you wanted to print thicker, because, by the way, the ohmic drop along these electrodes is 1 or 2 ohms. See this silver, this is basically silver chloride along here. That track has got a very low impedance, so you should be fine. The carbon is higher, it's got, you know, sort of hundreds of ohms, but of course your tissue has got really high impedance, so that will be the highest impedance part of the circuit. But we can print thicker. I don't think you actually need it. This is printed on a polymer, so it is waterproof, and you should be able to sort of put some adhesive on it. You use the word adhesive there. We do, at ZP, we definitely use pressure sensitive adhesives on these kind of materials, so you should be able to as well. Great question. Let me kind of guide you. And I just want to say, the way I imagine you're doing this is you may put a voltage across these 2 electrodes here, and you may put some tissue there, and that will kind of help you stimulate the tissue there. You're welcome to put the voltage between this carbon and this silver, or this silver and this carbon. You can obviously do that. And you could also, obviously, sorry, I just jumped too quickly. You could obviously also put tissue over here as well, and also address it there. So I think I understand what you're trying to do, and I think you're right. Our materials would work for you. And the beautiful thing is, I'm going to give you a link to this in a minute. You can buy them in sheets like this, so you can basically end up cutting out, you know, electrodes and sort of spanning your tissue across all sorts of gaps here. So you're not restricted to just one. You've got a whole sheet here. You know, you could have I'm just being a bit hyperbole here, but you can have a tissue going right across here. Now that's ridiculous, but I'm just kind of saying you can get them in this sheet format, so you can basically decide, I'm going to use that electrode and that screen printed electrode and this electrode over here. It'll come as one sheet. It's up to you how you then arrange the tissue on the sheet. It gives you a lot more versatility than you were otherwise, let's say, imagining. I will put a link, but you want this sheet of 300, and here is the link, and I'll put the link underneath the YouTube video as well. Great question, great application. I don't think you're a higher voltage. I don't think you're a high current. You can have different gaps between electrodes, and you know what? You don't even have to customize. You can just cut them out from these sheets, and you know, use your art and craft skills and get creative. Just a quick comment: you may need connectors, so I'm going to put a couple of links into here. If you're banana, so essentially you need to make good connection, otherwise you're going to be suffering from connection. So these connectors, one of them will work with 4mm banana plugs, and the other one will work with 2mm banana plugs. And I will put those links underneath the YouTube videos as well. Question number 2 is using our screen printed electrodes, and they're super keen to kind of go on to interdigitated electrodes. And I actually cut some slides from this, and I suddenly regret cutting slides because this person is interested in measuring signal using the capacitance element. I have to be really clear and say ZP uses these screen printed electrodes to measure electrochemical assays, and we use the capacitance region. The reason I bring this image up is because at ZP we have tried all sorts of geometries along the way. You see this interdigitated electrode here? This is not one of our designs, but you see this design here? This is effectively an interdigitated electrode. But we discovered along the way actually that these geometries really make little difference. Electrode geometry is important when you're large electrodes with large distances, you've got large currents, then it's important. But when you start getting down to the millimeter scale with microamp and less currents, all these different geometries, you know what? They make no difference. Well, no is a strong term, but they make little difference. If you're trying to make a capacitance measurement, these hypervalue electrodes work perfectly fine. Now, the reason I'm kind of concerned is because I think this will come up in my conversation about TRL3, Technology Readiness Level 3, going to Technology Readiness Level 9. When people start doing customization, there's a problem with customization. Customization, people want customization, which means low volume, and low volume means actually low quality. Of course, you can have high quality, but you have to pay a high price. But actually, that doesn't work in the research phase or in academia, where the budgets are not there for high price. So I'm really reluctant, and I really warn people about going after customization. It will just keep you in a technology readiness level 3 for too long, and you won't really make an impact in this world. And this week ZP did do a couple of webinars on our YouTube channel about how to make an impact from academia. So I'm really reluctant to say don't go for customization. ZP's put a lot of effort in making sure that our screen printed electrodes are really reproducible. And when you see demonstrations and come to a webinar tomorrow, for example, on the 23rd on our Sense It All platform, where we'll be demonstrating this, what you'll often see, this is not always universally true. Some of our assays we do calibration, but we at least have to have the mindset, no calibration. Why do we want no calibration? Because actually no calibration means no calibration, because we've got reproducible screen printed electrodes, leads to simple assays. Simple assays lead to technology readiness level number 9. Technology readiness level number 9 means you can get onto the market and you can actually make an impact. Now, questioner number 2 is on our screen printed electrodes, and they're kind of interesting going to a interdigitated electrode. But we've put so much effort into making sure that our screen printed electrodes are reproducible. We test our screen printed electrodes. So question number 3 is saying, well, how can you say your reproducibility is so high? Because we test and we test and we test. These are all, so what we've got here is we've got a run of screen printed electrodes. This is sheet 2, where we've selected something like 8 electrodes from it and we've tested them. This is sheet 6 from the same row, where we've tested 8 electrodes. This is sheet 18, where we've tested 8 electrodes. It may even be more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's 10. So 10, 20, 30. Here's another 10 electrodes, all being tested. So we are testing the reproducibility of our electrodes as a matter of fact, because lo and behold, we use them in our own products. What we sell on our web store is actually just a derivative of what we're making for ourselves. It's a very different business model. Like ZP is one of the few screen printed houses that actually consume more screen printed electrodes ourselves in our own products than we actually sell to the academic community. But the academic community then benefits from this. So what's going on here is, here we're looking at those sheets, so different sheets from the run. We have a mean peak current of 5.873, a standard deviation 0.344 microamps, a relative standard deviation of 6%. Another sheet in the same run has a mean peak current in that voltammetry of 5.803, a standard deviation of 2.94, and a relative standard deviation of 5%. Another sheet in that same run has a mean peak current of 5.988, a standard deviation of 0.379, and a relative standard deviation of 6%. The last sheet that we sampled in that run had a mean peak current of 5.793, a standard deviation of 0.328, and a relative standard deviation of 6%. Sometimes we actually do this at 3% relative standard deviation. So when I say we have reproducibility, we need it because we need it for our own products. We know we've got it because actually we do so much testing, and you may not be aware of it, but we're the only people with this cloud system called Julie, which we've built ourselves, which means that we can grab all this data automatically, analyze it automatically, and then able to prove that, you know, why we get such good reproducibility, or why we have such good reproducibility with our screen printed electrodes. So question number 3, this is my evidence as to why our screen printed electrodes are so good. This is some other evidence actually as well, that that means that because we've got good reproducibility, when we're testing at different concentrations, if I test low and then I increase the concentration and increase the concentration, I increase the concentration. Here I've got 3 electrodes, 3 electrodes, 3, 3, 3, and 3. These are all different electrodes. There's about 18 electrodes in this data set. But look at these this is 3 screen printed electrodes, all given a very similar signal. 3 screen printed electrodes, all given a very similar signal. This is reflecting the underlying screen printed electrode repeatability. So you can see it in our is our quality data, and you can also see it in our analytical data as well. So at Zimmer and Peacock, we make a really big effort to make a reproducible screen printed electrode. Why do we do it? Because we need it for our own products. What makes us unusual? Because we sell those screen printed electrodes also then to the R&D community, so everyone actually benefits from it. So when people ask me then for customization, I'm saying don't do customization, because customization is a custom electrode specifically for you. It's going to end up being low volume, unless you're paying a really high price for it, it's going to be low quality. So be really, really please careful with customization. But use our hypervalue electrodes, use our hypervalue carbon 501s. These are really reproducible electrodes. Cool. Question number 3. How can you justify that ZP electrodes are more reproducible than other electrodes? Because we have a lot of test data that, you know, we're able to kind of show evidence of that reproducibility. Do you have an Indian distributor? We do. This is his LinkedIn address. I'm going to put it underneath the video shortly on YouTube. Can we work on some collaborative projects together? We can, but I do get a lot of requests for collaboration. So I am sponsoring PhDs in the UK and Norway. I do lots of letters of support, but these are for people who have been supporting and friends to us for quite a few years. I was getting a message, but I was just looking online. So I just want to say we will do collaborative projects, but we do ask people to be supportive of us for a while, and let's see, you know, if you are supportive of us. Question number 4, really nice guy. I met this guy in Spain recently. They're a French academic group doing some really interesting work. I felt like the kind of work that they're doing really lends itself to actually coming onto this platform. Everything they're doing is ideal for this platform. They should be using our screen printed electrodes. I am super biased. I think they're really repeatable. I think they're even using carbon, which is even better because carbon is such a low cost material these days. Something I suppose I haven't added is that the hypervalue carbon electrode from ZP is about 90 cents each. So they're even, I think they're better quality than a lot and lower cost. Now, the problem that the other reason that you should be using screen printed electrodes from ZP is actually we have a vision for actually how to get people to market. So what's the problem in academia? It's actually impact. So I know some of you have seen these slides before, but let me just say, you know, that in academia, you're really working at technology readiness level 1 to 3. Technology readiness level 3 is a kind of, you're doing a proof of principle in the lab. But if you're going to make an impact, you have to get to technology readiness level 9, which means you're ready to deploy. And people talk about trying to cross this valley of death, and governments try to get involved. I think ZP, but this conversation about getting across this valley of death between academia and industry has been going on for 20 years, and it's not solved. I think we're the first company to actually, you know, ZP is different. Why should you use screen printed electrodes from ZP? Because actually we have a vision about how to actually get people to market. Most screen printed electrode manufacturers just want to make you a screen printed electrode, whereas ZP wants to make you a screen printed electrode in order that you can get to market. It's a different mindset. And so how do we close that gap? Well, we close that gap by having technologies that you can use in academia, which you can then also use in your products as well. So here's our SensiAll platform, which is actually utilizing our screen printed electrodes. So why should you use our screen printed electrodes? Because they're repeatable. What else? What? Give me a second reason. Well, a second reason is that they then allow you to use our Sense It All platform. When you're on our Sense It All platform, you're so much closer to making a commercially viable product. What makes the Sense It All a let's say a lab instrument is this QR code. This QR code means you can use Sense It All for doing open circuit potentiometry. What makes it a product? Well, this QR code means that it'll read a pH sensor. Can you see how quickly we can flip between open circuit potential, which is your R&D effort, and pH, which is actually an open circuit potential measurement? I had these QR codes, and maybe I'll just use my screen here. You know it, but you know the app that we have on our the app that you can download off the Android Play Store. Here I've got at the moment I've got it in a potassium mode. Let me go to the I got open circuit potential. Now I'm in open circuit potential mode, so now I can do open circuit potential measurements. There's one for amperometry here. So why should you use our screen printed electrodes? Because our screen printed electrodes are reproducible. Why else should I use the screen printed electrodes? Because the screen printed electrodes actually then allow you to use the Sense It All platform. Why should I use the Sense It All platform? Because actually it will do lab experiments, and you can then take it on. Here's a different QR codes. When I scan this QR code, it says sensor name. This QR code allows people to customize what this app will actually do for them, so they can put in their own assays, their own calibrations, their own branding. Suddenly they're much closer to product. So screen printed electrodes from ZP are repeatable. They make you much closer to TRL9 than you are at TRL3. The second thing they do is allow you then to actually have a roadmap onto the Sense It All platform. Why should you be on the Sense It All platform? Because actually then you can generally make an impact with your technology, and otherwise it just resides, unfortunately, in the lab. This instrument can do lab experiments, or it can be what we call a minimally viable product for actually taking to market. What's the problem we're trying to solve at ZP? I know you've seen this slides before, but let me just sort of emphasize the point. We think that most academic projects and most startups take 5, 10, 15 years. And especially with startups, you know, the success rate is about 10%, therefore the failure rate is about 90%. In order for people to succeed faster, we need to cut this down to about 2 years. So what the Sense It All platform, which is enabled by our screen printed electrodes, cuts away basic principles, technology concepts. It cuts away system prototyping, system complete and qualified, system deployed. System deployed. You can already download this app on the Google App Store and on the Apple App Store. So screen printed electrodes lead to the Sense It All platform. Sense It All platform leads to the ability to commercialize products. So I know you know this already, and I also want to emphasize to my colleagues in France and also my colleague in India, your value add is actually working on this part, getting that biochemistry right, but you need an underlying screen printed electrode that's repeatable. Where you add value is the assay and the sample upon which you're working. Where you add value is on the method file. Is it square wave? Is it differential pulse? Is it open circuit potential? Is it cyclovoltammetry? Is it EIS? Where you add value is that calibration curve. How to get from peak current, for example, if it was a voltammetry, to MIGs per DL, if that was the units that you were actually working in. So these are the places you add value. You can leverage that value if you're working on a repeatable screen printed electrode. If you're working on our screen printed electrodes, then suddenly you're actually able to plug into this, what we call a technology stack. The hardware exists. I know the hardware exists because there it is. I know that the screen printed electrodes exist because you can buy them on our web store. I've even got some here that we've taken along to a bit more of a product level. The app exists. If you rewatch this video and go back to those QR codes, you will find that you can install that app. Oh, the Julie database. Come along to the webinar tomorrow. Tomorrow I'll do a live demonstration. You'll see that every time that app runs, the data doesn't reside on the data. You get a result on your phone, but the data is saved in the cloud. That is so critical for when you're doing real world work with people who are remote from you. and actually it also has what's called an API, an application program interface, so you can plug into other people's clouds. That's really important for a modern, any kind of modern commercial business should have an API policy, and we've got API baked into this technology stack. Where you add your scientific value is what goes on that working electrode. That's where the IP is. Otherwise, everything else is in place for you. So as I say, you can get that. It's already deployed on the Google Play Store, on the App Store. These different codes just show you when you've got those apps installed, you'll find that actually you can scan these QR codes and you can go from assay to assay. Please do it. Please experiment. Please have a go. And you'll also find that actually that you can start doing you can start doing lab experiments as well. Amperometry, open circuit potential. Even though the glucose sensor is amperometric, we've calibrated, in the glucose calibration curve, there's the method file and there's the calibration. In the amperometry, it gives you much more of a scientific, let's say, experience. So one instrument can go open circuit or it can go pH. So please try it and give it a go. So electrodes for muscle stimulation, really good question. I don't think you need to thicken up those electrodes. I think the voltage and currents that you're passing are probably low enough anyway. The material we're using is water resistant. You should be able to use double-sided adhesive materials on top of our electrodes. Yes, you can space out electrodes in different dimensions, but actually that sheet I've given you will probably give you, or suggesting will give you, quite a bit of artistic license anyway. Question number 2. I do respect your wish for an integrated digital or a custom interdigitated electrode. Honestly, we've done a lot of work. It doesn't make any difference, very little difference, when going from rectangular electrodes, circular electrodes to interdigitated electrodes. I know there's a lot of literature around it, but I'm not sure that everyone has done all the kind of testing that we have done at ZP, and I do have pages on my website where I talk about the electrode geometry makes very little difference to the signal. The problem when you start going for customization is customization means low volume. In academia, there's not the budgets to pay a high price for that low volume. So low volume and low price will mean low quality. And if you go to other places, I appreciate you will find that actually that is the case. Why are ZP electrodes so good? Well, because we use them extensively in our own product. We have to really check the repeatability because many of our applications require no calibration. So if we don't have underlying repeatability of the electrode, then the assays that we're selling are not going to otherwise work. Question number 4 to my colleagues that I met in Spain but are from France, then I think the work that you're doing, especially in your carbon electrode, I think the carbon 501 will give you a repeatable electrode and give you a platform actually to come and, at the end of that PhD, you could even be making an impactful product from it because you'll be on the Sense It All platform. So with that, I want to say thank you very much. If you've got any questions at ZP, don't hesitate to reach out to us. Don't forget, there are 2 webinars tomorrow, one in the morning and one in the afternoon. They're on the Sense It All platform and they're much more commercially orientated because the people who are coming tomorrow are much more interested in sort of startup. But if you can attend, that's great. And if you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.